Okay. Define complex numbers. So Z is a complex number if and only if Z is equal to A plus IB, where A is real, B is real, I is not real, and I squared is equal to -1. The addition of complex numbers, well, that's Z1 plus Z2, which equals X1 plus Y1I plus X2 plus Y2I, which is equal to X1 plus X2 plus Y1 plus Y2I. Conjugate, I'll just put that here. Conjugate of Z is equal to the conjugate of X plus IY, which is equal to X minus IY. And then Z1 times Z2 equals X1 plus Y1I times X2 plus Y2I. So that's X1, X2 minus Y1, Y2 plus X1, Y2 plus X2, Y1. I think that's right. X1, X2, Y1, Y2, X1, Y2, X2, Y1. Yeah, okay, so that's that done. Let's have a look at the next part. Show that this is true. Okay. Z1, Z2 conjugate plus Z1 conjugate Z2. That's equal to X1 plus Y1 I think I'm going to be out of space here. X1 minus Y2I plus X1 minus I Y1, and then X2 plus I Y2. Multiply this out. That becomes X1 squared minus X1 Y2I plus X1 Y1I plus Y1 Y2 plus X1 X2. Oh, that should be 2. X1 X2, and that should have been X2. So X1 X2 minus X1 Y2 plus X2 Y1 plus Y1 Y2 plus X1 X2 plus X1 Y2I minus X2 Y1I plus Y1 Y2. So let's see, minus X1 Y2. Okay, so that cancels. They cancel. So you're left with X1, X2. Oh, there's 2 of them. Plus 2 Y1, Y2. So that's 2 X1, X2 plus Y1, Y2. Okay, and that's equal to 2, the real component of X1, X2 plus Y1, Y2 plus, and we can add in any imaginary part we want. So what I'm going to add in here is minus x1 y2 plus x2 y1. Now, because if you look at what you have here, this is identical to what happened when I multiplied these two brackets out. x1 x2 minus x1 y2 plus x2 y1 plus y1 y2. So this is twice the real part of z1 z2 conjugate. Okay, now we're required to prove that 2 x1 x2 plus y1 y2 is less than or equal to 2 the square root of x1 squared plus y1 squared and the square root of x2 squared plus y2 squared. So we can at least cancel the 2's out. So now we need to show that x1 x2 plus y1 y2 is less than or equal to feel like I want to square this. x1 squared plus y1 squared times x2 squared plus y2 squared. So hopefully I can prove this inequality with not too much difficulty. Okay, let me just copy that over into a new page. Okay, so I've just copied that over to a new page. Let's see. x1 squared, x2 squared plus 2 x1 x2 y1 y2 plus y1 squared y2 squared less than or equal to x1 squared x2 squared plus x1 squared y2 squared plus x2 squared y1 squared plus y1 squared y2 squared. Cancel. Cancel. So I need to show that 2 x1 x2 y1 y2 is less than or equal to x1 squared y2 squared plus x2 squared y1 squared. Okay. If I take that over to the right, x1 y2 squared plus, or sorry, minus twice x1 y2 times x2 y1 plus x2 y1 squared. That can be written as x1 y2 minus x2 y1 squared, which is obviously true. Whew, that was a long one. Okay, what is left now? So we have a couple of things to calculate and draw on the Argand diagram. Okay, this question's getting a bit long. I'll just do these quite roughly. Z1, 1, 2, 3, 1, 2, 3, 4, I1. Okay, so there's Z1, 3, 4, okay. Then 5 over Z1 is 5 over 3 plus 4i. Multiply above and below by the conjugate. So that would be 15 minus 20i over 9 plus 16. So that's 15 minus 20i over 25. That's 3 minus 3 over 5 minus 4 over 5i. So 3/5 minus 4/5, you know, be whatever. somewhere there. That's 5 over Z1. Z1 minus 2 is just going to be moved to the left here. And then Z1 plus I just gets moved up here. Okay, on another Argand diagram, show these two sets. Modulus Z equals 2, so that's just the circle here of radius 2, that's A. And then B, such that the argument is pi over 4. So maybe not the origin, but everything at a 45-degree angle here, and that's B. Yeah. Oh, and illustrate the intersection. The intersection is here and here. Kind of a long, messy question, but it's finished now. I hope I did everything and didn't miss a little sneaky thing.